Alright, so here we have a Toro 74237 tractor. That's a zero turn with a Kawasaki FH770D horizontal shaft 28 horsepower engine. I rebuilt this engine in August of last year. It's been running fine. Internals were a train wreck, basically got all new pistons, connecting rods, camshaft was snapped in half. It was pretty bad, but anyway. So there's an issue with the charging system on this one. Now in this particular model, the voltage regulator is right here, this device right here. So what it does, it takes AC current from these two wires, which come from the stator underneath the flywheel, and it outputs DC current. So I already tested to make sure we were getting AC here. We were getting maybe 35 volts or so if memory serves. I could be wrong, I'm just going off memory. And I checked this pin to ground, and we were getting DC out of there. So at least there is some life in this voltage regulator and the stator. DC comes out of here through this pin that I have hooked up to my meter right here, this green wire. And according to the wiring diagram, which I have printed over here, thankfully Toro is nice enough to post all this stuff online. I believe that would probably run directly to the key switch. So here's the diagram for this tractor. So we have, where is the charging system? Just looking for it here. Okay, I believe it's this B terminal here. Yeah, I believe that's it. And here's a nice diagram for the key switch. And here it says terminal A right here. Actually, it's not B, it's A. Is from the alternator. So let's find A on this diagram. So A is up here. So just tracing that back, it goes to a headlight wiring harness, which we don't have, and it comes from a violet wire from the voltage regulator right there. You can see that. So there's a stator underneath the flywheel. Well, you can see this. So AC, those two AC wires we just looked at. That violet wire comes out of the regulator, and it'll go to the key switch on terminal A. So I've seen a lot of these key switches go bad, so I think what we'll do first is we'll follow the testing procedure down here for the key switch just to make sure it's working okay. And I did pull this cover off already, and there was some suggestive behavior that might be a problem with the key switch. You can see this wiring harness looks a bit melted here, so I'm not sure what's going on. So I'm going to operate under the assumption there's a problem with this key switch for now. I'm going to test it, and we'll resume in a minute. We're also going to do one simple test too. We're going to test for continuity between that wire that looks green but it's actually violet to terminal A on this key switch to make sure that there's no break in the wiring from the voltage regulator to the key switch. Then we'll actually test the key switch. Alright, so I got my meter hooked up to that violet wire there, or the wire that's supposed to be violet. And I got it hooked up to the violet wires at the key switch. I actually disconnected it from the key switch, and we're getting about 60 ohms, which seems a bit high. That should essentially be no resistance because there really should be nothing in between there besides a fuse. So let's go and take a look at the fuses. There's a bunch of fuses. Whoop! You hear that? Hear that noise? That's the meter telling me there's continuity when I'm wiggling these fuses here. So we may have a loose electrical connection somewhere. So it's probably not that one. Probably not that one. Seems to be this one. So let's pull this fuse out. That fuse has seen better days. I don't know if you can tell, but it looks melted to me. So let's stick a new 20 amp fuse in there and see what happens. I'm not sure why that's 25. So I got this little fuse kit off Amazon a while ago. Comes in very handy. So let's yank out a 20 amp fuse. Much nicer. Now, fuses don't normally blow, so if a fuse melts or blows, there's probably something wrong that's causing that to happen. So you got to troubleshoot that root cause too. And what I like to do, these tractors get really messy, so I'll blow out all these electrical connections as I'm taking them apart. Because they get caught with grass and other crap in there, and then they get a bad connection, and then weird stuff happens. I also like to spray a little bit of this contact cleaner in there. So we'll hit that. Let me hit it again with some air. Alright. Let's plug this fuse back in and see how stable it is. So we still have some kind of weird intermittent electrical issue, so I'm going to dig into this harness a little bit and see what I can find. There might be a short somewhere in the wiring. Alright, so what I did is I just took a screwdriver and pressed on and cleaned up those terminals in there that touched the fuse that was all boogered up. And now this value doesn't change at all as I jingle the harness. Very little, which is fine. And also notice it was about oscillating between 20 and maybe 100 ohms. Now it's 0.2. So that's a very good connection. So we should be charging better now. So this is testing the resistance between the key switch and the actual voltage regulator itself. So what I'm going to do now is I'm going to branch out. I also cleaned up this terminal a little bit. It was a little corroded. I'm also going to clean up this switch right now with a wire brush. It is a little rusty. We have to have good connections here. I'm actually going to take that harness off, clean it that way. Where's my phone? There we go. So let's just make sure you guys can see this before I go any further. If anybody on this planet can figure out how to get a GoPro camera to work reliably, please let me know. I mean, really? It's connected right now. It's filming. Get support. Connect. Get support. I don't know what the issue is. This is the most unreliable piece of shit I've ever seen. But anyway, I digress. I apologize. So we're just going to disconnect this harness here. Just going to clean these up a bit. Ooh, that one's nice and loose. Look at that. See that, how it wiggles? That's probably part of the problem too. If that's not a good solid connection, it's not going to be charging. So we're going to order a key switch for this one. That whole terminal is loose. So that should get us back in business between a new key switch. That's probably why this terminal melted, because this got real hot because of this was loose. So we're going to order a key switch, and hopefully that'll solve the problem, in addition to cleaning up this fuse. So most of the time when there's an issue with these things, it's really not the engine. I mean, the voltage regulators do go bad from time to time, but most of the time it's the wiring on the tractor, and as you can see, this one's pretty old. So that should fix it. Alright, so the new key switch arrived for the tractor. Looks like the one that was in there was an aftermarket piece. This one is the original equipment one. Figured just to rule that out, we'll use the real deal. Stens also makes this cool repair harness for the ignition switch. That's the part number right there. It's 430-223. And it's basically just a harness pigtail that replaces that melted harness at the ignition switch. So all you got to do is just solder on your existing wires to those connections there, and you're good to go. The wire colors that come with the Stens harness are obviously going to be different than the ones that you have on your application. So you just have to match up the wire colors to the position in the existing harness. So you see here on this replacement harness we have red, blue, yellow, black, and white. On the existing harness we have orange, red, or I guess pink, red, black, and purple. So we'll cut this out and just start soldering on the new connections. We don't need much of a pigtail here, certainly not as much as we have on this the Stens harness. There's a lot of length there, and one of these wires crosses over to two other, well, I guess one other piece here. It crosses over to another terminal on the switch, and it goes to the PTO over here to engage the blades. So we'll mark these wires, cut them off, and put them on the new harness. Oh, I also got some replacement fuse blocks just in case these turn out not to pass muster. The ones in the tractor that we fixed the last time, we just cleaned up the terminals and put new fuses in there. So if we still have an issue, we have some replacement fuse blocks. If you've never soldered before, I recommend investing in a pretty high quality soldering station. I bought this Weller WES51 probably in the, oh geez, it has to be maybe 2001, 2002. Used it pretty heavily in that time period. A few periods of inactivity, but it's been very good. You can dial in the temperature. The newer models are much more sophisticated, but this thing is perfect because it has a small wand. You get into tiny places. These tips are replaceable. You're also going to need solder for electronics, and I like to wrap everything in heat shrink wrap. You get these kits on Amazon for a couple bucks. There's in a variety of sizes. So just a simple matter of cutting the wire to the correct length. Where did I put that harness? It's around here somewhere. Here it is. As you can see, I chopped off some of the loom. Going to cut these down to the right length, strip both ends, put a piece of heat shrink wrap over there, tighten the ends together, solder, and then use a heat gun to shrink the heat shrink wrap. Oh, that's the wrong drawer. So one of these, also something I bought a million years ago, this Milwaukee heat gun. So let's get started. Got our trusty wire cutters, our wire strippers. So we'll start with this terminal here, which is going to be a blue wire on this harness and a orange wire on that harness. So I'm just going to cut the wire off at this harness here. Put the camera on my head. Hopefully it behaves better this time. Did last time in the last video. So, snip here. Yeah, strip that end right there like so. Twist it together. That was orange, and we said it was going to blue. Obviously a much bigger wire on the repair harness. So let's get a piece of heat shrink that'll fit over there. This might do. Boot up our soldering iron. Now, sometimes it's easier to just shove the wire together like this and solder it like that, because if you kind of twist it together, it might get too big and you'll be able to get the heat shrink wrap back over it like that. So just something to keep in mind. There's a million ways to do this. And keep the heat shrink wrap away from the heat until you're ready to shrink it. And okay, there we go. So the flashing light means we're ready. We got some heat, got some solder. Let's get to town. Hopefully this cable's gonna be long enough. Put it on the beer keg. Now you don't necessarily have to solder these terminals. I suppose you could just use terminal connections and make it kind of something that can be repaired if needed, but soldering is just a bit more permanent. And over the long term, the connection is probably a bit more reliable. Put a little more heat into that. Doesn't take much, but I want to make sure it doesn't separate. It's not coming apart. Just blow on that a bit to cool it off. And just slide the heat shrink wrap over it. Oh, we get a little remnant. Cut that off. Come on. Tiny little hair. There we go. Then we'll power up our heat gun. It's an interesting sound. These things get real hot, so keep them away from things you don't want heat on. And that's about all it takes. And now you have a nice sealed connection there. Should last forever. So basically, you just got to do that for the rest of the wires. So we got 13.2 volts across the battery terminals with the motor off, and you'll see when I start it up, you'll hear an awful racket, and you'll see that spike up to 14.2. Before we weren't getting anything, we're just getting 12 volts. So that confirms that the issue that we had was with the overheating of the fuses and also the loose connection on the key switch, which you can see on this terminal here. That shouldn't be loose at all. So that was overheating. You could see a little bit of discoloration around that terminal. This looks like an aftermarket key switch Indac. They are a pretty well-known company, but I don't think this is the one that came with the tractor. I ordered a new OEM part and it was a little bit different. And the key and the terminals in the back are rock solid tight. So we'll crank it up and you'll see. So watch the voltage on the meter here. That's exactly the behavior you want to see. So you want it to see top out at around 14.2 volts. The voltage regulator should compensate for engine speed variations. If it goes wildly above that, the regulator may be bad. You don't want to overcharge the battery. You'll kill it just as fast as undercharging it. So I think this job is done. There is a possibility we might have to replace these relay blocks here. They get a little bit warm, but that just might be normal for this unit. This is I believe it's a 20 amp voltage regulator, rated for 20 amps or maybe 15, I don't remember off the top of my head. But this wiring is pretty small from the factory, so maybe it's just designed to operate that way. If not, we'll replace those fuse blocks there with something a little bit heavier duty. Hope that solves the issue. But for now, this job is done. Let's unplug the meter, and see you later.